Okay, so we're going to be focusing a lot on quadratics this chapter. So you will be an expert at it by the time you are done if you felt like last chapter was a little rough. Okay, so we're going to be asking a lot of the same questions. Hopefully you'll start getting the game after a while, or some of you might get it right away. Okay, the vertex, I don't know if you remember when it was with the x, it was not a straight shooter. So the x value's got to go there. Excuse me. The opposite of positive 3 is negative 3. Now, this is in vertex form. So if you look, there's nothing there. That would be a 0. All right. What tells you if it's going up or down? Whatever's here is going to tell you if it's up or down. If it's positive, it's going up. If it's negative, it's going down. So since that's positive, this is going up. Okay. Now, there is one transformation based on the parent function. Let me acknowledge that this is the parent function. So whenever you see anything else outside of that, that would be a change. The 1 doesn't matter because that's 100%, because that's your stretch or compression. You could also see it like this. There is no horizontal change, there is no vertical change, and it's 100%. So that's the parent function. But we write it as y equals x squared because all this extra is just getting ugly. Okay? So I'm going to look here. Now, whenever I'm dealing with pink, that's x. It's always horizontal. And then I have to think about, okay, is it a translation or is it a stretch compression? Well, stretch compression both have to do with multiplication. So I'm going to go like this. And excuse me, I'm sorry. My allergies are driving me bonkers. A translation is what's either being added or subtracted. So if you look here, it's being added, so it's a translation. And what would it be? It would be horizontal translation, 3 left. How do I know for sure? Look at this. If I graph this, negative 3, 0, there we go. Okay, I'm going to need my glasses for this. So let me remind you from last chapter, if you remember, quadratics always make a U. So that means whatever y value here would match here. Whatever y values here would match here. So whatever y values here matches here with the vertex in the middle. So if the vertex is in the middle and this is my vertex, let me zoom this out just a little bit. I'm going to put my vertex in the middle. Now I can pick x values whatever I want, but what I want to do is have them equidistant. So if I make this negative 2 and that's a distance of 1, I should make this negative 4. Let's say I decided to be fancy, okay? And I wanted this to be a 0. If that's a distance of 2, that has to be a distance of 2, so the y values match up. And then now what I'm going to do is I'm going to plug it in and make it work. 0 plus 3 is 3, squared is 9. So if that's 9, this has to match because the vertex is in the middle. Sorry again. So I have negative 2 and negative 4. I can pick either one, but I'm going to pick negative 2 because then it'll be positive. Negative 2 plus 3 is 1, squared is 1. And it matches. Now I can graph it, negative 2, 1, 0, 9. I know we're going to fake it. We'll be okay. Negative 2, 1, negative 4, 1, and negative 6, 9. If I go like this and I graph it, boom, there's my vertex. And this is going up. All right, let's try the next one. So when we look over here, we notice the horizontal was with the x. This 7 isn't with the x, so that means it's with the y. Which means, who are we talking about? Vertical. So do I have anything with the x? No, I don't. So there's my vertex. Whatever's in front, if it's positive, it goes up. If it's negative, it goes down. Now remember what we talked about. A translation is being added and subtracted, and a stretch compression is being multiplied. So this is being subtracted, so it's a translation, and it would be down 7. Why would it? How come it would be down? Because vertical is up or down. Okay? And where do I put my vertex? In the center. So let's say I decide to be a little crazy, and I decided to pick the number 2. If I decide to pick the number 2, what do you think should go over here to make it match? Negative 2. Good. Now, do you think I would want to pick? Now, I could, but do you think it would be pretty if I picked the number 1? No, because it's getting bigger and then it's getting smaller. So try to be consistent. You technically can graph it. It's just ugly and hard for people to understand. So maybe I'll pick 3 this time. And if I pick 3, what's going to match here? negative 3. And now I plug it in. 3 squared is 9, minus 7 is 2. That's 2, that's 2. 2 squared is 4, minus 7 is negative 3. And now I graph it. 3, 2, 2, negative 3, 0, negative 7. Now look at this. I don't even have to think as much, because all I'm doing now is I'm matching it up. And it is going up, and there's my vertex. Let's go to the next one. Vertex. Okay, well, when I'm dealing with my vertex, I want to focus on this. I'm going to put this over here. Y equals x minus h squared plus k. So when we're dealing with our vertex, we're dealing with our h and our k. We're dealing with our translation. So whenever we're dealing with vertex, we're only going to be focused on the translations. So if you look here, nothing is being added to the x, and nothing is being added to the y. So it's 0, 0. So the vertex is 0, 0. Now, is it going up or down? Oops. It's going up, because that's positive. Now, I have to decide if this transformation is a horizontal transformation or a vertical transformation. Let's remember from before. Remember from before, if it's with the x, then you know it's horizontal. And some of you go, well, it looks like it's with the x. Okay, let me get some scratch paper. Which one do you think looks like it's with the x? The first one or the second one? And you would go, oh, it's the first one looks like it's with the x, because it's literally in parentheses with the x. So this isn't with the x, it's just next to it. If I stand next to somebody, it doesn't mean we're together. But if I have my arm around them, you'd go, I wonder if they're together. So that means it's not with the x, it's with the y, so it's vertical. Remember, translation is add, subtract. A stretch compression is being multiplied. That's being multiplied. So how do I know if it's a stretch, and how do I know if it's a compression? If it is greater than 1, it is a stretch, and if it is between 0 and 1, it's a compression. So 3 is bigger than 1, so it's a stretch. Okay. Now when I graph this thing, I'm just going to not be fancy here. I'm just going to pick normal numbers. Why? Because I feel like it. Now, if I'm going to plug in a number, do you think I'm going to pick negative 1 or positive 1? 1. Good. 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. And now I graph it. Negative 1, 3, 0, 0, negative 2, 12. Now some of you go, wow, how come those numbers were so big? Well, if you vertically stretch me, you're pulling me up like this. If you pull me up like this, I'm going to seem taller, which means I'm going up a lot faster. That's when I was talking about taller and skinnier. Okay, one sec. Okay, vertex. Remember what the vertex is. It's the one that's being added or subtracted when it's with the x. Not a straight shooter. 1. And then there's nothing out here, so that would be a 0. So I got the vertex. Now how do I decide if it's going up or down? What's in front? It's positive. It's going up. Okay? Now, here's the thing. I actually have two things going on. I have the 1 happening, and I have the 13 happening. So let's look at the 1 first. The 1 is with the x. So that means the 1 is the horizontal. So I'm going to do this one. But then let's look at the 13. Is it with the x? No, it's on the outside. That means that is the vertical. So I'll put the 13, and that's the vertical. And now this means we have two transformations. You can move me and stretch me. You can move me and compress me. You can do two things. Okay? You can do a whole bunch of things. All right. Now let's look at the 1. Is the 1 a translation or a stretch compression? Well, it's being subtracted, so it's a translation. So that means this one is a translation, and it would be 1 to the left because, 1, sorry, I shouldn't be writing too much in pink. 1 to the right because not a straight shooter. Let's look at the 13. The 13 is being multiplied. So it is a stretch or is it a compression? Remember, stretch is greater than 1. This is between 0 and 1. 13 is way bigger than 1. So that means it's a vertical stretch by a factor of 13. So by a factor of 13. Oh, I didn't even realize that. It gave me the options. There were 2 options right here. I didn't even see that. I should have done it separately. Sorry about that. I'll do it for the next one. All right, how do I graph it? Let's do 1, 0. Okay, so I want you to think about how would this look? You're asking me to go, so here I am, you're asking me to go 1 to the right. So here I am, I make my U. Here's my original U. And now you're like, no, 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 go 1 to the right. So I go 1 to the right. And then you go, no, 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 no. Now vertically stretch me by 13. So I'm taking this and I'm stretching it 13 times. So now it should go like totally skinny, okay? If you vertically stretch me 13 times as tall, let's say I'm 10 feet tall. If you vertically stretch me 13 times the amount, I'm now 130 feet tall, okay? So I'm going to go 0, -1 because I feel like that's the easiest thing to do. I'll plug in, I can either plug in 0 or 2. I'm actually going to plug in 2 because I don't like negative numbers. 2 minus 1 is 1, squared is 1, times 13 is 13. 3 minus 1 is 2, squared is 4. Let me zoom out a little bit. Times 13 is 52. Oh my gosh, holy moly, I was not joking around. So that means it is going up super fast. All right, let's go to the next one. We actually have a lot going on here, okay? So we've got this. Let's deal with this one first. Okay, well that's this, and that would be 5. Where'd my pen go? And we're dealing with this. Straight shooter, that's 2. All right, is this thing going up or down? So there's a negative in front, so it's going down. Now, if it's going down, that means instead of my U up, it's down. That means it's a transformation. That's a change. That's what they call a reflection, okay? Now, what kind of reflection is it? Is it over the x-axis? Is it over the y-axis? If you remember, reflection means the opposite. So I'm looking at myself in the camera on the computer screen, and my right eye really looks like my left eye on the screen, and my left eye really looks like my right eye. Everything's backwards. So since this is with the y, it's really with the x. So over the x-axis. Now let's talk about the 5. All right, 5 is horizontal. Translation, 5 to the right. Let's talk about the 2. Vertical translation. Remember, straight shooter. 2. If I said to the right, would that be correct? No, vertical is up or down. And now I graph it. Okay? So what's going to go in the center? 5, 2, 4, 3, 6, 7. I'm going to pick 6 minus 5 is 1. Squared is 1. -1 plus 2 is 1. 7. 7 minus 5 is 2. Squared is 4. -4 plus 2, -2. So 4, 1, 5, 2. Wait, oopsies. Wait. 6, 1. Wait a minute. This is just the ugliest thing I've ever seen. 7, -2, and 3, -2. Which way is this thing going? Hey, it is actually going down. So it didn't change. It went, hey, go right 5, up 2. Okay? I'm going to do this last one on the next video.